Alright guys, this video is to help those of you that either were having a hard time in class today or in class we just didn't have enough time to talk about all that was going over in Chapter 6, Section 5 about increasing and decreasing functions. So let's do a couple here on your homework together and hopefully that'll get you up to speed. So take a look. First thing we're going to look at is what does it mean to be increasing or decreasing, or as this last option is constant. So let's look at examples 1, 2, and 3 on your homework. When we read a graph, whether it is linear like you see here on the front side of the page, or even if it's not linear like it is on the back side of the page, we always read graphs from left to right. And so we will read it, in this case for number 1, starting here and then working our way up. And the reason I say up is notice that the numbers on the y-axis are becoming greater as we go. So from left to right, this graph is trending upwards. So we say that, hey, this one is increasing, because the y values are going up as we continue along the path of that line. If we look at number 2, we would say that that linear function is decreasing. Again, reading left to right, this one is trending down. So this is a decreasing function. Now, last but not least, this last word, constant. A lot of people struggle with the meaning. All linear situations have a constant rate of change. What we mean by constant in this case are the outputs. How are the outputs changing every time? So in this first case, all of the outputs are becoming greater and greater. They are increasing. If we look at the outputs here, all of the outputs are decreasing. They're becoming less and less in value. If I look at 3, though, it's a little bit different. As I go across this line, it's flat. Okay, it's not sloping up or sloping down. It's flat. So all of these outputs, in this case, would happen to be a -4. They all are the same. In other words, they are all constant. All right? So increasing functions that are linear look like this. Decreasing functions that are linear look like this. And then, of course, constants will just be flat. They're not trending up. They're not trending down. They're just consistent. All right? So I hope you can finish up the rest of that first page. Let's flip it over to the next one here and see what we can do with these nonlinear situations. All right. Nonlinear situations. Okay, obviously a graph like number 13 here isn't going to be just increasing or decreasing. In this case, it does both. In the first part of the graph, it's trending down, and then it makes the turn and starts to trend up. So it both increases and decreases depending on where you're at. So let's write it out. First thing it does is it decreases. But now we need to say where. All right, so to do that, we look at the x-axis. Where is it decreasing? Well, notice it's decreasing, 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 and it stops right there. So let's go up on the x-axis. That's at -3. So all of my x values are decreasing until I hit at -3. So -3 is the stopping point. So all of the values that are on this side are part of what's decreasing. So -3, -4, -5, and so on. Technically, -3 doesn't count, but we'll include it for now. All of these numbers are where our graph is falling. So let's describe these numbers. How do they compare to -3? Well, -4, -5, and -6, they're all less than -3. So I'll say, hey, it's decreasing here where my x values are less than -3. So that's how we'll write it. Hey, it's decreasing where x is -3. Let's talk about where it's increasing. So in this case, it will increase where it increases at the following interval. So take a look. At -3 is where we make our jump. So we'll draw this direction. On this side of the graph, everything's trending up. Let's look at all these numbers. All of my x values on this side of -3, like -2, -1, 6, 9, they're all greater than -3. So I can say we're decreasing where x is less than 3 on this side of the graph. We're increasing where x is greater than -3 on that side of the graph. All right? So that begs the question. We've talked about everything that's less than -3, everything that's greater than -3. Well, what's so special about -3? Okay, well, here's the beauty of nonlinear functions. They have what we can call a maximum point or a minimum point. In other words, the highest point it will go or the lowest point that it will go. In this graph's case, it has a low spot. It will never go lower than this spot right here. And we talk about this case, it's a minimum And our minimum point we base on the y-axis. So I'm going to go over here and see where it falls. So it looks like it's at -7. So our minimum is where y is equal to -7. That's the lowest spot on the graph. All right? So this is how we'll do the rest of these problems. So let's try 14. 14 also increases and decreases. The first thing it does is increase. So let's write that out. So we're increasing. So this increases from where x is. Let's see what happens. It increases, 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 stops right here. It stops increasing. Well, that's all the way down here at 2. So anything on the left-hand side here, it's increasing. Well, let's look at all those numbers as they compare to 2. I'm looking at numbers like 1 and 0 and -8. All of those numbers are less than 2. So this graph increases where x is less than 2. All right, well, let's see where it's decreasing at. So let's see, this graph decreases where x is, and again, 2 is that point where it all begins, so 2. Let's look at the numbers on that side of things. Numbers like 3, 4, 6, 9, all of those numbers are greater than 2. So I'm going to say, hey, this graph decreases along those x's there where they are greater than 2. All right? Now, this graph's a little bit different than the first one. It doesn't have a minimum point. Okay? These two sides extend on into infinity, so there is no lowest point. But there is a highest point. Okay? We call that a maximum. Okay? This maximum point, if we look and trace it over, is where y is equal to 5. Cool. So where y is equal to 5, that is our maximum point, the highest that graph will ever be. All right. Well, let's do one of these that are kind of our what I call an S-curve or a Z-curve. These are cubic functions that make this sort of stuff. We'll show you one of those, and then we'll conclude the video. All right. Now notice this graph's even more different. Not only does it increase and then decrease, but it then increases again. So it has 2 times where it's increasing and 1 time where it's decreasing. Okay. If we look at other examples, we've got some here. Well, no, looks like they all do that. All right. So good. We didn't have any extras. So let's talk about where this one increases, because it does it twice. So this increases in 2 spots. So let's look. Increases, 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 stop. All right? That's here at -3. So when I write it, my x values in this case, okay, goes all the way up to -3. And if we look at it, it's all the numbers less than -3. So all my x values that are less than -3, hey, our graph is increasing. But let's continue on. This is going down, going down, going down, going down, stops, and then starts to go up again. So if I trace that point up here, that's at +3. So x at 3, it's also increasing, but let's look where that occurs. Everything else for the rest of the graph is going up. Numbers like 4 and 5 and 6 and 7, those are all greater than 3. So this graph increases where x is less than -3, so on this side, and where x is greater than 3 on this side. So that's how we'll write it. But what about this spot in between, this decreasing spot? Well, notice something. These x's fall between 2 points. So when I write where this graph decreases, I'm going to put x in the middle. Because x is actually going to fall, these numbers fall between 2 spots. -3 is on one side, +3 is on the other. We'll notice all these x values, and we'll color them in here in red. From -3 to -2 to -1, 0, 1, 2, all of those numbers are greater than -3. Another way of saying it is -3 is less than those numbers. So that's how we'll write it, that -3 is less than these x values where it's decreasing. Let's look at +3. Well, it's on this side. All the numbers here, like 2, 1, 0, -1, they're all less than -3. So all these x values are less than that +3. So this is how we'll write it. This shows us that -3 is on one side, +3 is on the other, and all our x numbers where the graph is falling, where it's decreasing, go in between. And we'll use less than symbols here to show that, hey, x is less than -3, or excuse me, x is greater than -3, -3 being the lowest number, and that 3 is larger than x, okay? So that's what's keeping it in bounds. -3 on one side and +3 on the other. Last thing. Notice this graph doesn't have a true high or low spot. This side goes on up into infinity, and this side goes on down into infinity. So it doesn't have any true highs or lows. Instead, we say that these graphs have what we call a local maximum or a local minimum. So in this case, my local maximum point, we'll abbreviate here for the sake of space, is right here. It's within this range that's going to be our highest spot. And if I'm reading this right, it looks like it's where y is at 22. So y equals 22. If we want to look at the local minimum point, there we go. Let's see, we go all the way down here and over. That looks like negative 14 or thereabouts. So y is a negative 14. So that's our local minimum, the spot on this graph where it happens to be the lowest. All right? So that's all we're doing today. So again, just to recap, on the front side, you're just telling me whether these linear situations are increasing, decreasing, or constant. So those are pretty simple. And then on the back, you're going to show me, hey, where are these graphs decreasing or increasing? And then what's their local minimum, maximum, or what's their absolute maximum or minimum? All right? If you have questions, come see me in class, and we'll be good to go.